Hello guys, welcome back to Tronics Energy, and we are still in our smart fan project. So today we are going to discuss on the two major methods in which you can control the speed of the fan. One of it is the linear mode method, which is the one we have been using all along, and the other one is the pulse width modulation. I know you have maybe heard of this in one way or the other. So we are going to start with the linear mode method. So in this method is one of the easiest method in which you can control the speed of the fan, just basically controlling the amount of voltage at the gate of the MOSFET using a pot meter. So the pot meter is connected directly to the supply 12 volt and the other side to negative. Then the wiper middle pin you connect it to the gate. So if you adjust the pot meter to either increase voltage, that increases the speed of the fan. If you reduce the voltage, it reduces the speed of the fan by reducing by either increasing or reducing the current that goes from the negative side of the fan to ground via the drain pin. Yes, so that's basically it. It's very easy, but this mode usually comes with its disadvantages, and one of the major disadvantage is that this method usually makes the MOSFET produce a lot of heat. That's why you can see today in my MOSFET right here. Let me just turn it off. I've connected a very big heatsink. So the main function of a heatsink is just to allow the MOSFET to dissipate the heat very well. Yes, so the heat is usually generated in this way because you are controlling the speed. Let's say you don't want the fan to run at full speed. Maybe you want it to run maybe at a low speed or just middle speed. The MOSFET is not at this mode, is not fully on and it's not fully off, so it acts like a resistor, and the easiest way to dissipate the rest of the power is through overheating. So that's why you connect it to a very maybe you just connect a small heat sink or a big heat sink according to how or according to how it's producing heat, and it usually protects the MOSFET from burning out or damaging the internal circuits. So this is basically how you connect it, and basically how the linear mode is not a very efficient method. Next here we have, so it's just basically it's just basically how we have been connecting it, so like that, and you just turn it on, and you control the speed of the fan via the pot meter wiper or the adjustment bar. So you can either increase the amount of voltage at the gate. Is now running at full speed, and you can reduce it to run at maybe middle speed, like that. So this is the region that I was talking about, the linear region, and it's a very inefficient point of running your system because it usually loses a lot of power, yes, by in the form of heat. That's why we have connected the heat sink. Yes, so let me just turn it off. Right next here we have the pulse width modulation. So this is just basically controlling the speed of the fan by connecting the gate of the MOSFET to a pulse generator. So I'm using an ND55 as the pulse generator, and we are going to adjust the speed of the pulses or the frequency using the resistance, which we are going to see in a few. So the ND55 gives square wave signals out of the pin number 3, which is the output, and these top regions we are going to call the on regions, and the bottom one is the off region. So basically, if you look at these two pulses, these two are different pulses. This is of high frequency and this is of low frequency. So this of high frequency, you can see the on time is long. Also, the short time is also long, but in this mode, it's very the fan is not going to have that effect of turning on and turning off. It's basically it's going to be seen like you are basically running it at a normal speed or smoothly. So the fan runs very fast in this high frequency mode, and in this bottom one, also the on time is equal to the off time, but this is going to be very distorted. So the fan once it goes on, this point goes off, then before it starts gaining the power to go on again, it would have reduced the speed at this point right here. So this is this is going to run the fan at low speed. So I'm going to show you what we mean. So if this is a MOSFET we are using, just connect it at that point. Then what else do we need? I have a small fan which I'm going to show you. A small fan. Basically it's also a 12 volt, but I'm going to run it at with 9 volt power supply. Yes, so this is just connected to the positive like that, and we get our 9 volt power supply, which is basically a battery, and we connect the positive and the negative. So right now it will run at high speed because I'm using a very low resistance right here, R1, so it's going to run at a very high speed. If we change it and use a very low speed, so let me just look for maybe a 10K, and you're going to see the difference. So this is a 10K, and I'm going to exchange this point to use the 10K. So right now it's running at, I can just see it's running at a very running at a slow speed as compared to the fast. You can also see the blades, meaning that it's running a very at a low speed as compared to using the 300 ohm resistor. So this is how you control the speed of the fan. This is a very efficient method because the MOSFET is not going to overheat a lot because it just gets the pulses, so it's going to have time to cool off. And yeah, so the circuit running at this is running. If you can see right here, it's running on and off, but in normal human eyes it's not possible to see those distortions. So that's why most of there are circuits which run with using this pulse width modulation, but it's not very easy to see because we cannot catch using a normal human eyes. You cannot see the distortions, but they are there. It's basically running on and off, but in the real in our perspective, we are just seeing it running at continuous mode. So this is a very efficient method in which you can control the speed of the fan. Yes, so this is what I wanted to show you guys. I hope you have understood, and if you have any questions, you can just leave them in the comment section, and hope to see you next time. So next time we are going to advance our circuit. The on time, or the on system, is not going to be a basic switch. We are going to put maybe a sensor to start it. So that's what we are going to do next time. Yeah, so thank you very much guys for your time. Please subscribe, and hope to see you next time. Goodbye.